All right, so officially, welcome to another session of our PEER discussion. And in today's session, we are looking at static libraries and command line arguments. Static libraries and command line arguments. From previous discussions, I've always said that whenever you are introduced to a concept in programming, there are a few things that you want to try and understand. The first is, what is this concept? Then you also want to know, why do I need to know this concept, or why do these concepts even exist? The next thing is, when will you be using these concepts? Then finally, you want to learn the application of those concepts. So we are looking at how to use those concepts. So we are going to start with static libraries. The question then will become, what are static libraries, or what is static library? Then we'll take a look at why do we even need it, when do we use static libraries, and how do we use static libraries. So if you get that concept, then it becomes easier for you, okay? So almost every concept, every new concept that we start from that angle. What is it? Why do I need it? And how do I even use it? So let's get our board ready. Okay. All right, so what we are talking about today is static libraries. Before I talk about what static libraries are, the first thing I need us to talk about is what a library, or what libraries are. Okay, in programming, you come across this word a number of times. Like, this is not the very last time you are hearing about it. This is actually the beginning of you hearing about libraries. So we need to get a full understanding of it. So what libraries are is, they are usually predefined code, or code that others have written that we can make use of in our own program. That's what basically a library is. So others have written the code, and we can just copy that code, not copy as in copy. We'll see how we copy it, but I mean, you can just go and grab that information or that code or program that you've written, then you use them in your own program. Okay, so it's like saving you time, instead of you going to sit over and rewrite the whole thing, like start everything from scratch. Somebody has created a library for you. Okay, so it's like somebody has created some set of code for you that you can just go and plug and play, if that makes sense. Okay, so the code is available, and anytime you want, you just go and pick it and use it. Sometimes in some other programming languages, we'll have it with a different name, like models. Okay, so pretty soon we'll be moving on to Python, and you'll be hearing models a lot. It's similar to the concept of libraries. Others have written a set of code for us that we can utilize in our program, so that we don't have to necessarily go and write the exact code that they have already written for us. Okay, so that is basically what a library is. So in C programming, we have two types of libraries that we need to consider. And the first type, that is what we are discussing today, is called static library. Then the second one is called dynamic library. And I think the name should give us a clue as to how they may behave. Okay, static. The name static means that it's not changing. At least, let's just get it from that name. Static means it's not changing, or it's fixed, something of the sort. It's fixed. Okay. Whereas dynamic means that it can be changed, or it changes over time, something of that sort. Okay. So we have understood the fact that a library is what? A collection of code that has already been written that we can utilize in other programs. even though I kept saying that a collection of code that has been written for you. It could be you, it could be that you are the one who is writing this set of codes. So I can sit down and write my own set of libraries and make use of them. But when we go to a programming language like JavaScript, okay, so when we talk about JavaScript, one library in JavaScript that we can talk about is React. For those of you who have been in programming before, you may have come across it, okay? And React happens to be a JavaScript library developed by Facebook. So Facebook wanting to develop their own library so that they can use it in producing other projects that they are working on. It's like they want to simplify how they work in JavaScript when they are working. So they developed React, and eventually they put React out there for everyone else to also be able to use them. Okay, so you and I can come together and develop series of libraries that will simplify the various tasks that others can use. I hope this makes the concept of libraries easier to comprehend. That is what we need to understand. I've realized a lot of us, we are trying to solve tasks but not understanding a concept. And that is the wrong focus. So let's focus on trying to understand a concept. A library is just basically a set of code or predefined code that we can write and reuse. So it makes our code reusable. We can reuse it anytime, anywhere, in any program at all. Okay, so basically that is what it is. Then we said that there are two types of libraries when we come to C programming. We have static library, we have dynamic library. And we said that from the name, static means that it's fixed. This library is fixed. Then dynamic means that this library changes. But the question is, why do we say static library is fixed? For us to understand these two concepts, okay, the static library and the dynamic library in C programming, we'll need to understand the compilation process of C programs, how a C program is compiled. We need to understand it. And if you remember the very first day's lesson at ALX, I mean first day of learning C programming, that's the first thing that we did, or that's the thing that we did on the first day. We learned how to compile a C program, okay? And we said that the C program compilation process is made up of 4 different arms. The first one being preprocessing. The second one being the actual compilation. The third one being assembly. Then finally, there is linkage. So if you didn't understand this concept from the very beginning, this is the right time for you to go back and try and understand how a C program is compiled, okay? And that's when we'll also be able to understand what the essence of the libraries are. So with preprocessing, which I think we've already discussed before, with preprocessing, what the program or the compiler is going to do is that it's going to pick all the header files. Okay, so it is usually focused on all the header files, and I think we'll get to see a lot more of them. The header files, so it's like trying to make sense out of the header files. Okay, so that's the very first place, the first thing that is done in the compilation process. Let's make sense of these files that you have included. Then after that, we are going to go forward to compile. That's the next one. You compile this, then you pass it to assembly, would assemble it into assembly language. That's like we are trying to reduce the code that you have written, even though you've written it in a language close to the human language. That is why we call it a higher level language. You have written it close to a human language, like in English. Okay, so your C program is written in more of English. We need to compile it into a language that the computer will understand. So we do that with the help of the assembly stage. So we are able to convert this to something that looks like machine code. Okay, then the final thing is that before we make this our program an executable file, that's a file that you can go ahead and execute. We then look for every other library which we have spoken about, that your code that you have written makes use of. Then we put them together. We link everything. So it could be that you have written a very huge program. Let's say you've written a software that has about, let's say, 50 different files. And each of these different files make use of certain libraries. So there are libraries available that we can use. That is, just as I explained, people have created some of these files, okay? So if these 50 C programs that you have written all make use of this certain number of libraries, and you want to put all of these into a single program, what happens is that after you've compiled all of these into the, let me say, machine code, or preferably object code, okay, they are close to what the computer understands. The next thing you are going to do is you are going to link this object code with any other library that you make reference to. So that's all that's going to happen. Now you have written your program, but your program makes reference, or it makes use of things that you have quoted from the library. So one thing that a library can contain, say, functions, a lot of functions. And for those of us in the ALX program, bear with me when I make reference to this, because I believe that once we are putting the recording outside, somebody who isn't in the ALX program may also have access to it. Okay, so I have to always make reference so that everyone understands what I mean. But I mean, if you have written, those of us in the ALX program, we have written a lot of functions, okay, custom functions, since we started programming in C. Once we have these functions and we want to reuse them in our program, we can put all of these functions into a library. Once we have put all of these in a library, it means that now in any program at all that we write, we can use, or we can make use of these functions that we have defined into a library. Then once we are making use of it, after we have done writing our program, we need to combine it with the libraries. So that process of combining your object files, so your object files plus your libraries, the process of doing this is what we know as linkage, or it is the linking process when it comes to the compilation, the 4 stages of compilation. The linking stage is where you combine your object files with the various libraries that we have. But this brings us to the types of libraries that we can have. So after we have linked them, we end up with what we call an executable file. That is a file that we can run to give us the results, or we can just run on our computer, okay? So that is what we call an executable file. But to get the executable file, there are 2 ways that we can combine the libraries with our object files. And that is what brings in the concept of static and dynamic libraries. If it is a static library, then what it means is that in this very linkage process before generating the executable, you are going to combine the libraries directly. So you are going to combine the libraries and force them, all your object files and all your libraries, force all of them into a single product. Okay, so you have a single thing that will be executable file. That is for the static libraries. So if you have a static library, all it means is that with this set of libraries, when you are compiling your code to get an executable file, that is a single file to be used, you will put all your libraries in there. On the other hand, for us to have a dynamic library, we rather will not combine it directly. So we wouldn't put the dynamic library, the file that makes up the library, we wouldn't force it into an executable. However, we will do something that will reference it. So in the case of the dynamic library, we can end up with something like this being our executable. Then we'll have our dynamic library here, okay, which is usually known as a shared file. Shared file or shared, yes, I think object. You can call it an object as is commonly known. Okay, so with a static library, we end up with just one thing, one file. So I can share that single file with you and you'll be able to execute it and everything will work. With a dynamic library usage, we'll have multiple files in that we'll have our executable, then we'll have our shared object file, which will be the dynamic libraries, okay? But this executable has references to this. So anytime that there is a call to any of these things, any of the things in this library, it knows exactly where to look for it. So if you end up running a program that depends on a dynamic library, in the absence of the library, the program is going to give you errors. And if you happen to use, I think Windows, I happen to use Windows, so I've seen it a couple of times. There are times that when you run a program, the program is making reference to a .dll file, which is missing. So maybe in your program, you ended up deleting the .dll file, or maybe the .dll file was flagged as a virus and your computer ended up deleting it. So when you are about to run your program, you get an error missing .dll file. So what is actually happening here is that your program is making reference to a dynamic library, which is this file, but unfortunately it can't find it. So if it can't find it, then it throws you the error missing .dll file. Okay, so a quick recap of what I have talked about right now. Let me confirm that this thing is recording. Okay, it's recording. So a quick recap of what I've said right now is that we have static libraries. And when you create a static library, you put it together with the object files to form a single executable file. Okay, so we'll have just one file. But when you have a dynamic library, we would have the executable file as a separate one. Then we'll have the shared object file too, which will be the library file. Okay, so let's assume that our library file is a DLL file, which is the case when you are on a Windows machine. So usually this is dependent on the type of machine that you are using. But we'll talk extensively about dynamic libraries later. For now, our interest is in static libraries. Okay, so we are using static libraries means that all we need is we need to compile our original code, which was written in C. And usually with the .c extension. We need to compile it into object code. Okay, object code will usually have the .o extension. Once we have all our codes in object code, we can then add this to the library that we have created. And libraries usually end with a .a extension. That is if we are dealing with static library. So if your library is called, say, my funcs. Okay, so we can have something like this: library my funcs dot a. Okay, and we end up putting these two together. We put these together to generate just a single file, which is an executable file. Then we say that we have used the static library. This means that the reason why we call it static, as I said earlier, static means that it's fixed. We can't change it. Once we have compiled these ones into an executable file, this means that we can make direct changes to the library that we have added. We can make direct changes to the library that we have written or we have added. And how is this? This is because you have just a single file. And this file isn't an editable file that you can just go into any compiler and go and edit it. No. It's more like you have now sealed it. So if you ever want to make changes to it, you have to go back to your source code. You have to go back to your source code, probably go and make changes to your library files, compile them into library files again. Then if you need to make changes to this, you have to go back to the source code, go and make changes to the code itself. That's the original C code before compiling them to object code, before recompiling them or linking them into the executable file. So that is what makes it static. The fact that once we have generated the executable file, we can't make changes to it. We'd have to go back to the original or the source code to make changes to the source code and recompile them again. So assuming you have written a program that you sold, and once you are selling it, you are definitely not going to be selling these ones, okay? You are rather going to be selling the executables. And after selling the executables, if you update it, it means that you would have to come and compile everything again. That is, you make all the changes. Then you have to resend a new executable file to your user. You have to make a new executable file to your user. So they will now have to probably uninstall this and reinstall the new one that you have. That is what makes it static. In the case of a dynamic library, if you want to make changes to just the library, we wouldn't need to recompile the executable. We'll just make the changes, and the executable can always make reference to the new one. So that is why this is dynamic, because we can equally make changes to it without starting from scratch. But for the static, we have to go back to the source code, go and make changes to the source code before we recompile it to get our executable again. So that is what a library is, and those are the two types of libraries. And I think practically too, I've mentioned the reasons why, kind of talked about why you would even need a library. Because I've mentioned the fact that a library is a collection of code that people have written. Okay, so if you need to write a huge program, sometimes you just rely on things that people have already written or things that you have written before. So you are coding currently, you are writing a lot of functions, you are writing a lot of programs, and eventually when you start building bigger projects, if you need to rewrite some of these basic things that you have written before, why will you waste your time to sit over it to write it again instead of just going to collect the ones that you have already written? So to be on a safer side, what you have already written, you just put it together as a library. So let's assume all the functions you have ever written, you put it together as one library. Then anytime you need to write a new project, since you have references to the codes or functions you've already written, you just use that as a library in your new project and you are able to utilize it. Any questions so far? Sorry. Yes, any questions?
Hey, I have a question.
Okay.
Hello, I have a
Yeah,
question.
go ahead. Go ahead with the question.
Oh, hello, can you hear me?
Yeah, Anita, I can hear you. Go ahead with the question.
Can you hear me?
Yes, please, I can hear you.
What is happening? Give me a
Oh,
minute.
We can hear you. Go ahead.
okay. Any other question from any other person?
Um,
Yes. Anita, we could hear you. So if you can hear me, you can always come back and ask your question. Any other question? If there's no question, then I I want to believe everyone here understands what a library is, what a
Hello,
static
Doctor.
library is. Hi, Tony.
I have a question. Like you made mention of a React library in JavaScript.
Okay.
Yeah. Can we say that the header files that we'll be creating, like the main .header file that we created, the main .h file, is that can we say that is a library? Can that be a library? Or could you just give us an example of a C library?
Okay. So that isn't a library per se. That isn't a library per se, because if you say a library in C, it has its format. That's something like, let's say when we are talking specifically about static libraries, then it should be a .a file. Okay, a .a file. So if you have a .h file, it wouldn't be considered as a library. And if you remember from the 4 stages of C compilation, you realize that the very first one, preprocessing, processes the .h files. Okay, the the library files are at the last stage, which is the linking stage where they come in. Okay, so you can't consider a .h file as a library file. That would be the major reason why you can't consider it as such. I understand why you are seeing it as such, but the structure of C doesn't allow you to say it is a library file. A library file is one that you have specifically compiled into a .a file, which we are going to soon learn how to compile it into a .a file. Once you have a .a file, you have created a library. Okay, so for instance, there could be, I haven't actually explored, that's why I mentioned in the beginning, I haven't actually explored the various libraries available, but there could be a library for, let's say, math functions. I think I've come across one like that. And that will mean that the library looks like this, libmath.a. Okay, something like this is a library available to the compiler that you can use. So others have written a set of math functions that you can use inside your program. And if you want, you can also decide to write your own set of math functions and call it anyhow you want. Okay, so assuming that you're doing a certain math project and you're not finding any standard function inside any of the libraries that are available to you, you can basically go ahead and create your own maths library and call it, say, my maths library. So we can have something like mymaths.a as the library that you have created. And you can also make this available to the public. So you probably publish it online on your GitHub account, make it available, or probably open source so that others can equally add on to the library, something of that sort. Okay, so that is basically what the library is. I don't know if I've answered your question.
Hello.
Hi.
Yeah. Good day.
Good day.
Concerning this example you gave now, it will be kind of I don't know if you can illustrate it better, but let's say we have a some kind of mathematical or physics, kind of formulas, and we decide to have them packed into a library. I don't know how you can do that, though. But now, when we do that, how do we integrate it in a way that we can actually make our calculations easier, so that we don't
Okay.
need to be writing formulas anymore? Can you
Okay.
illustrate? Yeah, thank you.
Yeah. All right. So the next thing we are going to look at is how to use the library. So we'll cover all of that. Okay. For now, let's understand what a library is. I mean, the difference between a static library, the dynamic library. Then we'll just quickly get into how to create it and how to use it. Okay. But basically, in summary, let me try and summarize this, trying to answer your question. So once you have created a library, which we are going to learn how to create, once you have created it, you now have access to all the functions in there. Okay, all the functions in there, you have access to them and you can use them in your program. So let's assume, please, I'm saying let's assume. So please just bring your imagination cap, and after we are done, just throw it away. Let's assume that all the functions that we've been working with so far, printf, scanf, and the rest, let's assume that they are put into a library that we are actually going to use. They are in the library, and when we are compiling it, we use the library. All we need to know is what their prototype is. Okay, so that at the end of the day, when I'm calling a printf function, I should know how the arguments are passed within the printf function. When I'm calling a scanf function, I should know how the arguments are passed. So you remember that here it should take an address of something. Okay, that is all you need to remember. You don't need to know the definition for printf. You don't need to know the definition for scanf. We are not concerned about this because it has been made available to us. So in the same way, if you have defined your own function, say you have defined a function called cosine f, you have defined a function called those things. How do you have what? Cosine and what? Sine. Yeah, I think there is sine f and things. Let's assume you have defined these functions and you have put them into a math library. Anytime you need to use them, you just go ahead and use them, depending on how the prototype is. Do you pass argument to it or not? So if your prototype asks us to pass argument to it, then you just go ahead and pass the argument. Then use it like that. Okay, so let's get a bit practical. From previous lessons, what we've done, we have already created functions like underscore putchar, which is more of a replica of the standard function putchar. Okay, so let's assume that this putchar function, underscore putchar function we created. Now let me just call my own say cosine. Is it? I think it's cosine f, or let's use sine f, and say sine f takes an integer and it returns an integer. Okay, this is sine. Hey, please let me. Okay, so it takes an integer, then it gives us the sine value of the integer we pass to it. Okay, at least these are some mathematics. It's been a very long time since I did anything of this sort. Anyway, so let's say sine f is a function we've created that gives us the sine of a given value. And we have a lot of these. Okay, so we can have cosine f, we have their definitions. I can't define it right now, actually, because I don't know how we'll derive the sine of a value. But I mean, you've written, you know what you're about, you've written your function.
Area of a circle, something very simple to
Come
carry
again?
out. Area of a circle, like
area of a circle. Okay, I think now. So C area is a function that will take an integer rad, say the radius, okay, and say it's going to return an integer. Let's play with it. It's going to return an integer. So what's the formula for area of a circle? Area of a circle is what? Pi r square. Or is that it? Is that it?
square.
I think it's pi r square.
Okay. All right. So we have this. It's been a very long time since I did mathematics. Okay. Anyway, so let's say we are returning pi r square. Where r? Okay. Let me use r here instead of rad. Okay. So that's what we have. So we have this function, and in fact, we have a lot of these other functions. Let's say we've created them. All of them are available to us. So all we need to do is go and put together a library and call, maybe the library will call it libarea.a. So this library contains functions for determining area of stuff. Okay. And we all know, like, you know what is in there, what's available. So the fact is that if you are writing a library for others to use, you have to write a documentation for that library. Okay, I think later in the course we will come to learn about documentations and their importance, but we would have to write a documentation. In fact, almost any program you are writing, you have to come up with a documentation. So as part of the documentation of this library, we'll talk about the prototypes to use. Okay, the prototypes to use. We'll talk about like sample usage. Okay, so we'll tell them if you want to use, let's say, this particular function, then C area, you just pass a value in here, say 8. Okay, this means that you're checking for the radius of a circle. Sorry, you're checking for the area of a circle with radius 8. All right, all this information is available in documentation for those who do not know what you wrote in your library. They're just going to use your library. Your library has been compiled into a .a file, so I don't need to go and open it and see what's in there. In fact, it's just an archive of object files, and I can't make meaning out of object files. So what I'll need to know is what your documentation tells me. Okay, so I'll just go and read the documentation about it and see, okay, this is how we use C area. So anytime I want to use C area, I'll use it this way. So now that we have this library at our disposal, when I write my C program, any program at all, and I need to calculate, maybe inside that program, I need to calculate the area of a particular circle and use it for something. Okay, what could be a practical example where you need the area of a circle before you can do something? So let's assume that I'm writing a program that is going to calculate the volume of a cylinder, sort of. Okay, this afternoon my mathematics is coming back. We are going to write a program to calculate the volume of a cylinder, and we need to know the area of this particular cylinder. I mean the top part or the bottom part, which is the circular part. Okay, so our C program that we are writing is actually interested in getting the volume, which is this, I think so. Okay, but we have a formula for calculating this already. That is a function available to us with this. Okay, so all I need to know is what is the radius if r is equal to 4. Then this my program will just call, say x is equal to C area 4. This means that this x is going to return the exact value that 8 is going to give us. I mean, this area formula is going to give us, okay? So let's assume, I'm just giving a value. I can't compute it right now, okay? So let's assume s is equal to 20. Then we'll come and use it in our formula. Say v is equal to 20 times h. And depending on what h is, if h is say 5, then we are getting v is equal to 100. So that's basically how we use it. So we use your library just as you use any of the functions that you've been using right now. Any of the functions that you've been using right now, you've been using printf. How do you know the definition of printf? No, but there's a documentation on printf. That's the person who taught you C programming taught you that when you want to use printf, you have to use it this way. There is the format specifier has to be here, and this value has to be here in order for it to work. Okay, but it's a similar thing. So all these other functions that you are using them because someone else has created them. So it's like there is a library available to you that you are using. But now,
sorry, you mentioned that we have to have the prototype. You know, the true prototype. Yeah. We have to have it in our mind, and I think we have to put it in our code. Like in this, we are talking about area. So we are going to include. First of all, we are going to be including the prototypes at all the prototypes that are inside the library. In the code that we want to make use of the library.
You are going to use the prototypes of the functions that you use. So there could be millions of the functions in there, but you're not going to use all of them. So you don't need to include a prototype of all of them. But the very ones that you use, you have to include their prototypes.
So in this case, I think we can sideline the need for the list.h or a main.h that we usually create, where we have to store them in a particular file. We can.
Why would you want to sideline them?
Because of there is a library, there is a static library containing all these prototypes, and we are actually calling we are actually making sure we include the prototype in our code. So why the need for that this thing again?
You realize that your library contains object files that was obtained from your C files, not your header files. Okay, so it's not from the header files. So your header files is equally important, like it's still important. That's what I'm saying, that well, you have your definition. This library contains, what does it contain? Definitions. It contains definitions of the various functions, if we are talking about functions in our case. It contains the definitions of the various functions, okay? So for us to be able to use a function, we've already discussed, there are 3 things that we need to always have. First, we need to have the definition of the function. Then we need a declaration of the function, which is done with the prototypes. So we have created a header file, in our case, main.h, that contains the prototypes. And that is what the declaration is. So before we even go to find out what's in the library and object files, we'll need a preprocessor to preprocess the header file. So it's important. You need to include any of the functions that is available in your library that you are going to utilize in your code, which is the last part, calling. That's calling the function. Any of the functions that you are going to call, you have to provide its prototype here. So what I said was that after you have created your library file,
Hello?
Please give me a second. Let me finish this one. Okay, I'm coming. After you have finished with your library file, in your documentation, you need to provide us with information about the various prototypes that are available in that library. Prototype. Okay, so that if I want to use your library, when I come here, I should just look for the prototype for the function I want to use. So maybe I want to use C area. I come into your documentation to look for the prototype of C area, add it to my header file. Please, let's always remember, it is for us, we have chosen to call our header file main.h. We could call it anything.h, okay? But what is important is that any function at all that you are going to be calling in your program, even though you have captured the definition inside the library, you need to put the prototype of that function inside your header file. Okay, so in simple terms, whenever you want to use a function, there are three things you do. You define, you declare, and you call. Okay, so with the help of libraries, the definition can be encapsulated, or abstracted rather. So we can hide these ones with the help of the library. It's like my program now wouldn't contain this. I wouldn't need to define any of the functions. I've hidden them. They are hidden in what we call a library. Okay, but I'll still need to declare them. So in my header files, I'll need to declare them using their prototypes. Then once these things have been achieved, I can go ahead and call the function. I hope you are answered. Yes, you can now go ahead and ask your question. Sorry.
Yeah, hello. Sorry if I may say something. The other guy
Yeah.
that speak earlier that said we don't need to declare the prototype. The guy is right in the sense that everything in C is actually a function.
Okay.
You get, and all these things have been declared by. Okay, for example, let's say you are calling the standard library. You are all the standard library string.h, std something. All those things are you are making reference to the library. You get.
Okay.
And that particular file, which is the other file, in the case of stdio now, it's already existing in a C standard library. You understand?
Yeah.
So if you want to use any function inside that library, for example, you want to use the printf or the scanf, those things are function on their own. You don't necessarily need to make or declare their prototype before using them. You can just use them directly. Prototype essentially just inform maybe user okay, this is what this function is going to return, and this is the argument it's going to take, and the argument types. Yeah, am I making sense here?
Yeah, you're making sense, but I think there is something that you should. Okay, you finish.
Okay. So essentially, we are letting people know that okay, this is the prototype of this function. Is very good. Get in your documentation. But if you want to write your own code and make use of them, you do not necessarily need to write the prototype first before using them. Once you make a reference, you call it in your header file, because ordinarily C does not expect you to use a function before declaring it. You have to give the prototype first before using the function at all. So if you are making reference to the header file from the library before making use of the function at all, so I think that should be fine as long as you know the prototype of the function you want to use. So you don't have to spell it out fully before using it. That's just my contribution.
Okay, so I think there is just something you are missing up. That's all. What's happening is that the header file, any of the header file that you are talking about, header file contains prototypes. Okay, so to be able to use printf, scanf, and co, you go ahead and call your stdio.h. They contain this file that you are calling contains the prototypes for those functions.
Okay.
So without the .h files, that is without the header files, you can't use the functions. Okay, and that's basically what I'm saying.
I understand, but the thing is, that header file does not necessarily mean that it contains your prototype alone. It can contain your whole code. For example, if you want to write a different code and you need to segment it, you write one function in one file, another function in another file, another function in another file. Let's say you have 16 files for your own program. Of course, you don't want to write everything where you're going to have hundreds of thousands of lines. You want to break them down in chunks. So if you want to let's say I have file A and file B. from file B, if I want to make reference to file A, that's why that is containing the code itself. I cannot make reference to it unless I declare it as a header file. I like make the header file of file A, then I call the include the header file of file A into the file B. Then I cannot make use of the functions in file A. You understand what I'm saying? So that means I can write a whole code. That header file that I'm calling, it could be a whole code, like full code itself, not necessarily just a header file. But as long as I declare the header first, then I'm calling it. So that will work.
The last bit that you have said, I'm trying to understand it, but I don't know if what I am thinking is that it's the same thing that we are talking about, except that you are probably seeing it from a different angle. Okay, so what I've said right now is that with a library, you have the definitions of your functions. Okay. If you don't create a library, you can still create your functions and even put them, it could be in the same program. Or it could be in a different file. Once you are compiling it, if it is in a different file and you are compiling it, then you have to compile. So for an example, if I've created, let's say _put char.c, if I've created a function like this, okay, and it has a function, I'm using it in my main.c file. When I'm going to compile this, I have to compile both of them. Okay, so I have to do this together with put.c. Okay, but for main.c to have access to this, there should be a declaration that main.c have access to. So inside main.c, if I decide to include a header file that contains the prototype of this, then that's going to work. If I leave that header file out and I don't declare the prototype to main.c, that function _put cannot be used. And that's the same thing I'm saying, that even if you have all your functions in a library and you're going to use them in a specific program, say main.c, you'll have to declare it for main.c to see that, oh, I'm going to use these functions and this is how they look like. And how do we do that? To simplify it, we can put all of them into a header file. So you can create your own header file and include it in main.c. Once you have included it in main.c, it's like you have declared a prototype there. Okay, so the standard ones that we are using, they are standard library files that we all understand, fine. But until you include their header files, you can't use those functions. So you can't use, let's say, even scanf. You can't use it if you didn't include the header, the standard library file. Okay, I mean the header files that it requires. So that is basically what I'm saying. Without the header files, if you leave the header files out, you can't use the functions.
Definitely.
Exactly. So the header files.
Okay. The point I'm just trying to make is that the header file doesn't necessarily have to contain the prototype alone.
No. It doesn't, like, it's not only just prototype. I understand. Okay. But for a header file to contain the definition of the code of a function to is not appropriate. It can contain other things that we'll start looking at it. But the definition of the function shouldn't be in your header file. Your definition, that's why we are having a library. So you create the library, then after you have created your library with all your functions, you can then create a header file that you put your, your prototype in there. So in simple things, let's assume that right now all of us have agreed that we are going to build a very good library that we can utilize in almost any program. So we are going to create all our functions and put them together in, say, almighty function, something like that. Say we have almighty library, and that library is going to contain. What we can also go ahead to do is we can go ahead and create a prototype, a header file called maybe a almighty header file. And what it means is that anytime you include this header file in your program, you have access to all the functions in the library that you created. Okay, so the function definition shouldn't necessarily, you shouldn't go and put your function definition in the header file. Even though the header file doesn't only contain prototypes, there are other things it can contain, but you shouldn't put definition of your function in a header file. The definition of your function, if you want to make it reusable, should go into a library that you can use. I don't know if probably we are talking about the same thing. That's what I keep saying. But if I understand it.
To bust my head. Header file, library, header file, library. I don't know because that is what they call the header file that they say is a library. Header file being a library. Now I'm still hearing header file and library and trying to distinguish or associate both of them. The thing is now tingling in my head. How the comparison going on here? Please clarify me. I want to get lost.
Okay. In order not to get confused, this is it. Simple thing. Look at these two things. I said to use a function. To use a function, we have what? We have definition. So you define your function, then you declare your function. Okay. So these are the two things that you are hearing about. The definition of the functions are put into a library. So C compilers already come with like libraries that are inbuilt, sort of like it comes with the programming language itself. That's now we all know how to use. And for each of the functions here, they have been declared in header files. Okay, that is, their prototypes have been put in header files. And these header files, like they are different ones. I mean, the libraries too, they are different ones. Okay, so for instance, you have probably come across stdio.h. You have come across stdlib.h. Okay, so these are just containing header files from specific libraries. But you and I, we don't even need to know what is contained in the library. No. Now it's just because we are trying to learn how to create our own library. That is why we are wearing our heads around it. For us to be able to use these things, okay, all you need is the documentation that tells you how to use this library and how to use their header files. Okay, so don't get confused. There are two things. To use any function at all, the first thing you do is you define the function. So the definition is what? Now we've defined a lot of functions. There are a lot of functions out there. You've defined them and you've put them together as libraries that anyone can use. Okay, but these ones that you are talking about are standard ones. They are in C, so you don't need to even worry about it. The compiler will do everything. Like, we don't get to see those ones. Okay, then when you come to the header files, they are just declarations. Without the declaration, you can't use the function. That's simply what is happening. Okay, so it's like the header files are like files that are also included in the compiler knows where they are as part of the installation. They are there, but as they are there, they are containing the prototypes to the various functions that are available in the library. So in the same way, if you also are going to create your own library, after creating your library, you still have to create something like a header file that anybody at all can use. So you can also go and write your documentation explaining how people will use it. And anytime they want to compile their program, they just have to compile it with your library files, usually a .a file, since we are talking about static libraries, a .a file, okay? And they would have to include a header file. So depending on how you call your header file, .h.
Wait. Now, I think there is standard library, and there are header files inside the library. I want to be very clear what is happening. There is standard library, and there is header files inside the library. Now, there is local headers. There are local headers. That's the one we create our own main.h, and they can be put inside the static library. All right. So if in the case now we want to compile, can you just write a simple way in where there is the code is given now? We want to make sure that we are using the library and the header, and then we are compiling. How would this be putting down in this thing in coded form or in interpretation so that we can actually execute it and see that we know what we are writing down? Please, that's what I want to know.
I'm trying to make this the simplest way possible, but okay. So the reason why I think you are getting confused is because you kept hearing standard library files.
Yes.
Standard library. Okay. And they say to be able to use the standard library files, you have to write the header file. That's, let's say, stdio.h. Okay.
Yes.
So what I'm saying is that the standard library files are actually library files that you are not seeing. Okay. They are library files that you are not seeing. But to be able to use them, these libraries contain definition for various functions. Contains definition for various functions. So your printf, your scanf, your put char, they all have definitions. Okay, and those definitions, where are they kept? They are kept in what we call standard libraries. But unfortunately, you cannot see it because it has been put together into a program that like your computer knows about. Okay, so it's able to give you the outcome that you are looking for. But to be able to use any of the functions in this standard library, you can't just go and use them. You will have to declare them in your program. So even though they are available to your computer, before you use them in your program, you have to declare the functions that you are going to use. How do you declare a function? Simply put the prototype in the function. So when you come here and you call this, let me go to a compiler and see if we can program is the common one that we use. Great. So what you are seeing here that we are including, okay, this is a header file. What does a header file contain? You know, what does a header file contain?
The input output, how will I call it? Standard input output. That's it contains functions like printf, the put char, the put. You can these are
what you need to know is that it contains their prototypes. That's what it contains. Good. It contains their prototypes. So all the functions that you have mentioned, their prototypes are kept inside this file. Okay, but their definition is kept within a library or various libraries that you and I do not see. Okay, so that's what you need to understand. These are prototypes, like the prototypes are contained here. All right, so when you also want to create your own set of functions, underscore put char, whatever that you created, you ended up also putting your prototypes into another file called what? main.h. So you were able to come and use underscore put char here just because you made reference to this. And this contains what? Prototype to this underscore put char. But now you are putting all those functions in a library. So there is a library that contains all the definitions. But inside the program that you are writing, you don't need to bring the library here. So we are not going to be importing the library here. All that we need to use here is a prototype to that those functions that we are going to be using. Okay, so this contains the prototype. But eventually, when we are compiling the program, we'll need to pass the library that we have created. So with the standard library that C comes with, automatically it forms part of the compilation. When you are compiling it, automatically C compiles it with the standard libraries. So if and only if you use the prototype, then you can go ahead and use the function. But if you didn't include a prototype, then you can't use the function. In the same way, if you also create your own library and you don't include a prototype to that library functions, those functions that you have created, you can't use those functions in your program. Is it any clearer?
Yeah. I get it.
Sandeep,
So
what I can add is
okay.
Then,
so the declarations of these printf and scanf, they're in the standard library.
exactly.
Then the prototypes are in the stdio.h.
Exactly. So that's how you should understand that the normal standard library files that we talk about, okay, they are not files that we see. This what we are calling standard library files. They are files that contain the definition for all the popular functions that we know of. Okay, so the definition will be in there. And in fact,
sorry, and if the thing now that I want to wrap up, I get what you're saying. The thing I want to wrap up is the shortcut. The shortcut with the use of the static library in compilation process. You get? So what are we supposed to, like, we are putting all those files that we compiled in C into object files, and now they're actually bearing under the static library. What are we eliminating now when we are using the static library, doing the static library compilation, as we have written the code totally? What are we going to be including, or what are we excluding from that compilation?
Okay, all right. No worry, we'll get there soon.
Okay.
Yeah. All right. So I'm just hoping that we understand this basic part. Okay. So the whole thing is that we have a set of, let's say, files. Remember, when we say a static library, okay, a static library is actually an archive of files. That's what it is, an archive of files. It's a set of files put together. So let's say this is made up of, say, the first one, second one, third, fourth. We can have a lot of them. And each of these, if in our case, because we are dealing with functions, that's why I keep using just functions for the explanation. So assuming that each of these files is a definition for several functions or a single function, okay, that is what we've put together as a static library. This is there, it's available for use. But to be able to use it in our program, we need to have the header files. We need to have their prototypes. Okay, we need to have their prototypes in our program. So you can decide to put their prototypes into what we call a header file. If you don't want it that way, inside your program, maybe inside main.c, you can declare all of them, but it's not appropriate. So you go and create a header file that will contain all of them. So in simple terms, what I'm saying right now is that if you go ahead and write your own library, as we did in the task that we were given, if you write your own library, I think that one, the library was called something like this. After you've written this library, okay, if you are going to publish it for other people to have access to it, you can't just publish only this alone. You have to publish it with what your header file contains. So you have to create a header file, say my.h, okay, and this should contain the prototypes to all the functions. So pass it the prototype to all the functions that you have in here. then tell us how we can use it. So inside your documentation, you give us all the information. So if I want to use this your library, I'll just come and pick file 1, file 2. Okay, then inside my program, maybe inside main.c, I'll include this my.h will be included inside my file. Then I can now use any of the functions that is available here. Okay, so this is how libraries are created. So now if you have a library and you want to make it available for public use, you would have to go and push that library there, give us header file. So for instance, if I go to my GitHub account right now, the libmy.a is there, the main.h contains all the prototypes that are available in libmy.a is also available. So anybody at all can use those two in their program, okay, which we are now going to learn how you are going to use them. But you can use those two in your program and use the functions that are defined in there to write your program. Please, that's all I want us to understand, okay? Like, sorry. You just need to understand that. Smith, we can't hear you. You're speaking, but we can't hear you. We just need to understand that, okay? There is a library, then there is a header file. Both are needed for our program to run successfully. Once that is understood, the next thing we want to know.
Okay. Sorry, I wanted to say something. If I get the static library, okay, just the way we have main.h. So actually, main.h is supposed to be a kind of library, but it's something we use per project, maybe per file. But the static library is supposed to be like an archive of all the functions that we have probably been using, so that we can easily access them any day, anytime. So, but the static library now is now some of the functions are split into different parts. Like a different file has the prototype, a different file has the functions or something. If I get this right.
Yeah. I'm coming. Let me try something. Hopefully. All right. So what? Yeah, boss. I'm trying to answer your question. Okay. So what's happening is that as we have been writing programs, like since we started writing C program, you realize that most of the time your program is just a single file program. Okay, but that is not the normal way programs are. Like a program, see, you are using Telegram right now for this thing. You think Telegram was just a single that they created? No, like a program is made up of a lot of files. Okay, and if it is made up of a lot of files, it means that there are a lot of these functions that we are also going to make use of. Okay, so what we have done is, when you look on my screen right now, over the period that we've been writing programs, we've written all these custom functions, okay, that we want to be able to use if we are writing a very big program. So now what we are saying is that when we are going to use that big program, or when we are going to create that big program, we want to be able to just make reference to any of these and use it as and when we need. All right. So we've put this together, all of these files together as an archive. Okay. And those ones contain the definitions for each of the functions there. Now, in the main program that we are going to be running, we need to make reference to these functions. How do we do that? We always do that with the help of a header file that is containing the prototypes of all the functions. Okay, so the main.h that you have been creating is just a file containing the prototypes or various functions that you are going to be using. And that is like the normal way things are, because almost every now and then when you are building a program, you have a lot of files to work with. And the only way that you can have access to something that you have declared or defined in a different file inside another file is when you declare it inside that new file. And you can easily do that with a header file. So that's basically what's happening. So in this our case, for instance, we have all of these. Let me go ahead and delete this. Sorry. So for those of you who haven't seen what's in the library file, this is what is in the library file. When you open the library file, this is what's in there. Oh, I want to delete it so that. Okay. So what's happening here right now is we have a number of. Oh, this thing is frozen. We have a number of functions we have created, okay, that we want to be able to use this set of functions anytime, any day. Okay, to be able to do that, we are going to put it together into a library. In simple terms, we are going to pack all of these files into a single file. That is all that it means to put them into a library. We are going to put all the files that you see here that are functions that we have created. They are custom functions that we have created. I want to have them as just a single file. And when they become a single file, it is known as a library. Once it is a library, okay, now let's ignore the fact that it is a library. Let's ignore the fact that it's a library. If I want to use putchar inside a function that I create, by now you know that let's go and create. Do I have a main.c here? Okay, no, so there's no main.c here. So let's create a main.c. So there's a main.c here. Okay, now please kindly hold on. My door is making noise. I'm coming. All right. So back to this. Now, if I want to make use of putchar, somebody should tell me. If I want to make use of putchar inside main.c, what do you think I should do? To be able to use putchar in main.c without getting an error, what will I have to do?
You will have to have the function, this in char prototype in
The
this
prototype. Thank you very much. So I'll need to come copy this. Okay, copy this, then come and declare it here. Let me just copy. Okay, I want to do lazy man's work right now. Copy this and paste it here. Okay, and okay, so what you realize is that without the prototype for put underscore, so let's do this. Let me delete printf. Putchar, without a prototype for putchar, this is going to give me an error. Okay, and you see the error here is implicit declaration of function. So it doesn't know what putchar is. So the only way I can use putchar is by declaring or adding the prototype. So let's copy this, and paste it here. Paste it here. Once I paste this here, now it's going to allow me use putchar, okay? Because it knows I'm coming. Okay, so at least this should work. Hey, I just saying too many elements. Wow. Okay. So I think depending on the definition. Okay, so this should work. All right. So now let's see what's happening. Without this, we can't use this function. Okay, and the error we'll get is implicit declaration. But once we put it here, we can go ahead and use this. Okay, this is basically what we are doing right now. This function is in a separate file. Okay, but we can only use it after we have brought this thing here. So what we are doing when we mention a library is that we are putting all of these files into just a single file. Okay, so instead of having individual files, we are just putting it into a single file that we can reuse anytime we want. But to be able to use them, we'll still have to come in here and bring for each of them. So to use this one in your function, you need to have the prototype. So for each of the functions in your library, you would have to include a prototype in here. Okay, but imagine if you have thousands of these functions in your library. Are you now going to put every single one of them here? That isn't an ideal way. So what we decide to do is, let's put all of them into a single file and make it a header file. So say we put it into main.h, then we'll bring main.h. So what does main.h contains? It just contains a prototype to all of these functions. So basically, there are two things that are happening here. Like, you just need your files that define your functions. Once you have those ones set, the next thing is you need a file that contains the prototypes. If you don't have a file that contains the prototypes, then you would have to define or declare them one after the other for you to be able to use it. It's similar to everything we've been doing so far. It's no different. The library is just you putting all of these together as one file. As simple as that. Okay. Now, practically, how then do we go ahead to create the library? That becomes the question that we should be looking at. And that was what our task in ALX was about. Okay. So let's use the shell to do this. Ordinarily, when we are running a program and we don't want to generate a library per se, we just want to run it straight ahead. What do we use? The command that we have been taught to use is the GCC command. Okay, so you can use GCC to compile your code, but you should also know that GCC can take various options, and depending on the option that you pass to GCC, it will either go to just do the preprocessing, or do the compilation, or do just the assembly, or do all the four. Okay, I mean up to. So preprocessing up to compilation up to assembly. All right, and if you recall, the very first task that we did in C programming was about this thing, that they say write a C program that write a script that will just compile a C program and return the output of the preprocessing, or the output of compilation, or output of the assembly. All right, so we need to know the various options that we use to get any of them. Okay? So you realize that to get just the preprocessing, we use this option, the -e. So -e will give us just the outcome of preprocessing. If you want the outcome of the compilation, that's from preprocessing to compilation, the two of them, you use -s. I think the S is capital S. Or you have to confirm that whether it's capital S or small s. I've forgotten. But it's -s.
Capital S.
It's capital S. Okay.
This one is capital S.
All right. Thank you very much.
Hello.
All right. Hi.
Hello.
Hi, Rati.
Yes, I have a question
All right, go ahead.
concerning the shell, like when they give us that web terminal, right? And then I try to compile, say for example, my prototypes are in main.h, and then that is a separate file, right? But then I'm trying to run, say I'm trying to run, maybe let's just call it putchar.c, but we have the file separate. So when I put GCC now, and I'm trying to run it on the web terminal, it says it does not recognize main.h. Like it does not it does not know that I have a main.h, and hence I always have a problem trying to compile using the web terminal. And
when you are compiling, for instance,
my IDE. Yes.
All right. So when you are compiling, for instance, in this particular case, okay, do you include the main.h here? Do you include it?
No.
So that's the problem. No. It has to be. It's part of the files. Once you've left it out, it's trying to find the file and you can't find it.
Okay. Thank you very much.
You're welcome. All right, sure. So the options is what we need to understand right now. Now the last one, I said there are 4 stages. So the first one is what? The preprocessing, and we said we use the capital E. If you want to go beyond the preprocessing and get just the preprocessing and compilation, then we are using the S. But beyond that, if we want to generate the assembly code or the object code, then we use -C. Okay, so this is what we use to get the object files, right? This is what we use to get the object files. Once we've gotten the object files, remember that I said the library is an archive of object files. So if you want to generate a library, what it means is that first of all, you have to compile all the files that you want to put together in your library. You have to compile them and use them to generate object files from them. And after you have generated the object files from them, you can then put them together as an archive or as a library file. Please do you understand it? The options is there are 4 steps. 4 steps: preprocessing, compilation, assembly before linkage. After we are done with assembly, we get object files. Okay, and when you want to create your library is made up of object files. So you can't just go and put these together, the C files together raw like that. You have to first convert them into object files, then put the object files together as a library. To be able to convert, yes.
Hello.
Yeah.
Alpha. Hello, Alpha.
Yes, I can hear you. Or are you not talking to us? Oh, okay, good. All right, sure. Okay, so as I was saying, this will help us generate the object files. Okay, so that's the first thing we want to do. So in this case, let me first of all get rid of this, because my interest is building a library file right now. That's what my interest is. So I'm trying to put together all these functions which I've created into a library file. And I have said that the very first thing I need to do is convert all these C files into object files. That means that they should now have the extension .o. Okay, so in the first place, let's go ahead and list. Let's list, because I think I created them earlier. Okay, so now let me first of all remove these files before we do them again. Okay. All right. Great. So now, as you can see, let me clear the screen. So when I do ls, these are the files that I have. I have .c files, but I want to convert them to object files. So to do that, from what we have seen so far, it is gcc-c. Then I have to list all of them, okay? All of them. That is too much of a work for me right now to list all of these. So I can use this .c. That tells me that for all the files ending with C, I want to compile them, but I want to compile them into object files. Okay, so when I go ahead and I hit enter, now it's going to generate the object files for us. So let's do ls and see. And as you can see, for each C file, there is now an object file. For each C file that is available, there is an object file. Any question? Okay. Once we have gotten the object files, now we need to put them into an archive. And that is when we can say that we have a library. So we only need to know what is the code you can use to put these things into an archive. The code to do that is AR. Okay, archive, AR. But when we are creating the archive, one other thing we need to pay attention to is it could be that you have already created the file, or this is the first time you are creating it. Okay, so the AR command also takes some options, and the options here, in order to be on a safer side, is to use both of them. That is RC, where R is like recreate it if it already exists, and C is like create it. So if it doesn't exist, create it. If it exists, recreate it. Okay, so it's like I'm creating a new, maybe I've made some changes already to my library, so the old one doesn't matter. So I need you to recreate it if it already exists, and if it doesn't exist, go ahead and create it. All right. This is it, and I need to pass a name. What's the name of the library that I'm going to give it? Or what's the name I want to give to my library? So whatever the name is, you have to preface it with lib, L-I-B, then the name of the library. So in our case, we're asked to use my. Then the extension is a .a. So that becomes the name of your library. Lib my.a becomes the name of your library.
Doc.
Hi.
I want to know why are they using .a for the library?
Dot what?
A. For
Oh,
the library.
I can't really tell, but obviously, what would be the best answer? Like, okay, what I can say is that this is the standard that has been created for us. So if you are working with a static library, the extension is .a. Okay, so I don't think there should be a peculiar reason. I don't know if there is, but I don't think there should be.
Because
The
files are for objects, I think.
Relax. Yes, one after the other.
I read a material that they said that .a should like be like you collecting all the object files together. I thought that's supposed to mean that, but I'm not sure, Sean. I'm just thinking.
I think the A stands for archive. So every static library has that extension .a.
The archive. Okay. So that would make sense. All right. So A stands for archive. I think that makes sense. Yes.
Can I just continue something? Extensions, I believe extensions are standard. It's just like if you compile, maybe you have a collection of songs, we have different formats, like MP3. Where you say, okay, this is MP3, you know that, okay, anything that has MP3, it has a low megabyte. Anything that has that maybe wave it's heavy. So it's just like even in video, you know, there are MP4, there are MPEG. So all these things, they have different people. So it's just something you need to just accept that, okay, library files are .a file. Anything that has .a file, once you come across it, you know it's a library file.
Right. Thank you very much. All right, so that makes sense, and I think just as it was said earlier, A represents archive. It makes sense because I know that with the dynamic library files, they do not end in A. So .a is for static library files. Okay, so the dynamic, I think that is depending on the device we are using, but commonly we use the .so, which is shared object. Okay, but some will also be DLL, as I suggested. Windows machines will usually be DLL.
Sorry. Now, in the light of what they are saying here, I actually think that we can actually, rather than converting to O files, we can actually pack all these files and put in this library, these .c files. Although I don't see the use for that, but I think if you can actually pack all these files with this same command, arrow minus arrow c, you can actually pack all those files and put inside this library. This library that we are creating, and to end the .a, without giving you without me making the file look like something awkward. So the extension .a, I don't know what it means, but I don't think it's really peculiar to the standard static library.
I was trying to really understand what you said, but anyway, the whole point is that, just as I've said, we are interested in creating the static library. Some of the things you come to meet them and you take them as they are. Okay, so we are saying that for a static library, the extension is .a. Somebody has said that .a represents archive. We know that a static library is an archive of object files. Okay, so we are just going to put all the object files together, then we'll have an archive of it. This shouldn't really be something difficult for us to understand. I think with even the example Smith gave us, it should make, for instance, the common ones that we all know. If you have, let's say, a number of image files, say JPG, if you have a lot of them, or even PDFs, you can archive them into a .zip file. Okay, we'll get .zip. That's just an archiving process, or a process of compressing them into a single file. And that's exactly what we are doing in this particular case. We have various .o files, and we are combining them into what we call a .a file. So I don't think this should be really a problem or anything difficult to understand. All that you need to know is that whenever you use this AR, okay, this AR to combine .o files, the outcome is a .a file. Just keep that in your mind. Okay, I don't think it should be a problem. All right, then now we need to pass to it. What are the O files that we want to compile? All the O files that we currently have in this location, we want to compile it. So let's do this. Use the wildcard to do that. So asterisk.o, meaning we are compiling all the O files into a library called libmy.a. All right, so just hit enter. Then when we list, we should find this library now amongst our files. Where is it? So this is the library that we just created. Okay, on my left hand, you can see it here. So now we have created this library. I can download this library and make use of it anytime, anywhere I want. Okay, but to be able to use it, I shouldn't forget the prototypes. Okay, So in our specific example, we decided to call the prototype main.h. We could have called it anything. In fact, I would want to even rename it to my.h because my library is called my. Okay, so if it is called my.h, that contains the prototypes. So anytime I want to use this library, the lib_my.a, I have to get this file, then I have to get this prototype as well to be able to use it. You get it? So I can go and create, let's go to Replit. Let me create a new Replit. Okay. So here, if I want to use any of those functions that we have already created, we have access to. So I want to use, let me delete this and say I want to use underscore put char in this case. Okay. In this case, say I want to do this. You realize that I have an error here, and the error is implicit declaration of function. This means that my program does not understand this underscore put char. This is the first time it's meeting it. Okay, so I've already created a library that it can use. For that matter, I'll need to download this library. I hope I can download it. Download the library. Okay, I think I already have it in there. Then let's see, I've not even tried uploading. Okay, I think we can add, okay, upload a file. So let's try uploading it here. Okay, great. So now we have this here, and I think we need one more thing. That's the header file. Okay, download. Then we come here and upload this. Okay, so now we have this here. I can decide to include it in my code. I include my.h. Once I add my.h, you see the error here is gone because now my program has access to this prototype just because I included it in there. Okay, if I go ahead to compile this time around, I have to compile and get the object file. Then I'll now do the linking together with the library files. Okay, so that's where the difference comes in. What you have here right now is you have a library file, or you have a number. You could have a number of library files, and you're now going to compile them. Hey, sorry, so I left something out about a library file. After you have created a library, okay, there is one more step, very important step. You need to do indexing for the functions. Okay, just like a dictionary is a very big book. Without the index of a dictionary, okay, for dictionaries, guys, it's going to be easy because they're in alphabetical order, so you can easily open alphabetical order. In my practice at pharmacists, we have this list of medicines books that we use, and they are not in order, alphabetical order. Okay, so it becomes very difficult opening such a book, and you need the help of the index. So anytime you want to access any medicine at all, just open to the back, check the index, find a page where you can find it, and just go there. Okay, so after you have created a library that is made up of a lot of functions, in fact, this is small. You can have a library that is made up of thousands of functions. And if that is the case, we need to index it. Okay, that is like creating an index so that our program can always easily find what it's looking for. Okay, so basically we need to create an index for the library that we have created, and we do that with the runlib command. Okay, so runlib, and let's pass the name of our library, libmy.a. Okay, then this will help us create the index for the various functions that we have in our library so that our program can easily access them. So we can go ahead and run this, and now go ahead to download it. Go ahead to download it once again. Then we'll upload it to where we are working, okay, so that we'll have the index file here. All right. But when we are going to compile this, the first thing we are going to do is to compile up to object code. So we'll have, first of all, let's do ls to get the files here. ls to get the files here. Okay. So don't mind some of these files. The main debug make file Replit, that is just for the platform that we are using. Okay. So we do not need those ones. All right. But let's see. So GCC, then we want to compile to object files, the main.c, then the my.h. Don't forget that one, main.c and my.h, okay? Because the header files have to also be included. After we have done that, we should now get the main.c object file. Okay, so this particular one, even though it was, I think because of the platform, it was already created for us, the main.c, but it doesn't matter. So now that we have recompiled it, we've gotten this main.o. So after we've gotten this main.o, now we have to do linkage. So we have to link this main.o with our library itself. That's where we are now. We have to link main.o with our library, and that's we are going to do with a GCC command, okay? But with the, hope I've not forgotten this, with the option L, okay? Then it takes the name of the library that we are going to add, the name of the library, and the name of that library. This time around, we are not going to include the lib and the extension. The linker already knows that for each library that is going to add, it has to have lib in front of it, and it has to end it .a. So all you can do is just you link it with my. That's all. Okay. I think there's something more. Forgot. Okay. So I think this particular option tells it where to look for the files. Okay, so it should look for all the files in the current directory. Then let's do main.o. So by doing this, we should be able to generate the executable, and that is how we use our library. So we could have had a lot of libraries and would have added it in here. Could have had a lot of object files. I would have just added them in here directly, and once we run them, okay, so let's do gcc-l my main.o. Can't find this. OD returned one as a status. I'm missing something. I think that's so.
Try an hyphen before the capital health.
Come again. Sorry, Mike, I didn't hear you.
Try and hyphen before the big L.
Oh, okay. Let's try that. Still saying that no such file or directory. Oh, why am I making silly mistakes like that? Wow.
Are you hearing me?
Yeah, I can hear you.
Okay, what you write? Write GCC minus L dot, that capital L dot. Yes, then you have minus small letter L my, and then write main dot C, not main dot O.
Okay.
We still give you error.
All right, so don't worry, I'll rectify it and get back to everyone on it. But in essence, that's what I want us to appreciate. So what we have done so far, let me go to the board.
I actually think that you need to create a name likewise when you're doing the compilation. I don't know. You didn't create it. Okay.
That shouldn't really be a problem. But anyway, just as I said, I'll check up on it. As I said, I haven't really gotten time because I've not been feeling well, so I haven't gotten time to practice a lot of these things. But anyway, what I'm saying so far is what we have done. The first thing was in creating so that's what we need to know. Creating our library, okay? In creating a library, we needed object files, okay? So for all the functions that you want to put together, into this library, you have to compile them into object files, and you do that with the You do that with a gcc.c, okay? And probably if you have all of the C files within one location, then you can do this to generate all the object files. Once you have the object files generated, you then need to create the archive. And you create the archive by using the AR-RC. Then you pass it the name. Okay, so library name, let me say library name dot A. Then pass it the object files as well. So in our case, we pass all the object files that were available. Then the next thing you need to do is index it. So you index it with can you imagine? This thing just escaped me and I can't even remember. Runlib, whether it's run or rad. Runlib.
Runlib.
Interesting. Runlib. Then the name of your library. Okay. So that will be used to index it. After you've gone through this process, you've gotten your library. Now the next question is, how do I use the library? That's what we're trying to do, and we had some issues. I'll rectify it and share the information with everyone.
Based on the ALX, I saw they have another flag minus O. That's hyphen O, which we did not.
That's for output.
Okay. Another thing I wanted to talk about, I didn't hear you talk about was in that prototype .h file. It was not guarded. I don't know if by not guarding it, that's supposed to be an issue we will be dealing with. It was not guarded with the indef and then define and endif. It was not guarded with those macros. So could it be an issue, or is it important in any way to do it?
It's important. It's important. If you don't do it, you get an issue. So it probably escaped me, that's why. besides, like some of the things we've already done them, so you don't expect me to just go back to everything, okay? But thank you for bringing it up, and hopefully everybody appreciates that too. What's the thing I was going to say? Object files, archive, index. Okay, so the next thing is using the library. That's what we're on. Using the library. Hey, guys, this thing has taken so much time. Using the libraries. So to use the libraries, you would first of all have to compile your code. So that's the first thing. The code that is going to, or the program. Okay, sir.
When you wanted to create your library, you used AR-RC, then you included the object files. Why are we including the object files to the command?
Yeah, so as I said, creating a library is basically an archive of the object files. That's the .o files. So that command without the .o files wouldn't make sense. Okay, so basically all that you are doing is that, hey, I want to create an archive of some O files. Okay, this is what it means. I want to create an archive of these O files, but at the end, I want to call that archive my.a. Okay, and I'm passing this option to this command to tell it that if it is already there, recreate it. If it is not there, create it. Okay, so in essence, this is like an argument. This command has to take this argument. Like it needs the O files before it will compile them. Otherwise, what are you compiling? I hope that answers your question.
Yes.
Now that okay.
I think in line with what he's saying, that if for a reason now we left one object file outside the compilation, we can actually add that file singly by writing ARO minus ROC minus libmy. Then you have the file name .o. And then do this include this single object file that was not included before. I think that should help to add up to the other object file that we are in the inside the static library.
Okay, I hope there's an information you are passing around.
Yes. So that's what I'm saying now. If it's like this asterisk.o is like a white card to add all the object files. But for an instance now that you have an object file, a particular one that was not included, you can actually do it individually and do ARO space minus ROC libmy, then the name of the object file you want to include. Just write it down .o. And you add that one up to the list of the libraries that were existing.
Okay, all right, thank you. So using the libraries that you have created, so now we have created a library called libmy.a. We are saying that to be able to use this, you first of all have to compile your program to object files. Okay, so that's the very first thing you need to do. And to that, we use the GCC-C. But this time around, when you quote whatever your .c programs are, you also have to include all your header files that you are using. Okay, if you created header files, you have to add them. Then eventually you are going to get the object files, so .o files. Then after getting the .o files, we can now link the object files and the libraries. Okay, we can do that. So I'll find the appropriate code for this step and share it as soon.
Sorry, please. I don't get the first step on that. Using the libraries. That's the compile the program. Sorry, can you explain?
Yeah, so what I think practically what we did here was we created this main file. Okay, so if you pay attention at the top here, I had to compile. But if without the -c here, it's going to compile and give you an executable. But this time around, I want my executable, that's a final file, to have access to the libraries. So I compile the files just as I would have done normally, but with the -c, and that gives me the object file. Then I can then go ahead and link them. Okay, so that's basically what it's saying. The compilation, when we use compile in C, okay, like it's a broad term that probably encapsulates this. Let's check. Okay, so until you explain what you mean by compilation, that's usually a problem. But this will involve what this stage, because of this option, will involve the preprocessing, will involve the compilation, assembly. So this is where we are going to end for everything that we pass to GCC. We are going to end here and get the object files. After we've gotten the object files, we can then use the linking to complete it. And that's what I said, that I'm going to share the code or command to do that.
Sorry, Mo, I want to be very clear about this. Must you compile the prototypes.h file?
What do you think?
I don't think you need to compile the .h file.
Why?
I mean, we like you said, you're wherever you're going with this if you want to use this static library in another set of codes, if you want to export it to somewhere else and use it, you also have to have this your my.h as well. You also have to take it down. So what is the essence of having the object file of .h? If you're going to be using the prototype, you're still having the prototype, making use of the prototype wherever you want to use it. So why have this in the library?
Don't forget the 4 stages, please. There are 4 stages that needs to be done for the. What's the role of preprocessing? What happens there?
The preprocessing processes the files.
Which files?
Header files.
Header files. So if you don't do it, where will your header files be?
Okay. I don't know.
That's the very first step. You are talking about the last step, which is linkage.
Okay.
So if you didn't pre-process your header files, how do you then get to linkage and say that I had header files there?
Okay, thank you. I get it now.
You're welcome. Is any other question? I don't think we can take the second one because it's past 3 already. Any other question? Static libraries alone, I didn't imagine it would take this long. So for the purpose of those who joined late, just a quick summary. When we say a library is a set of code that has already been written that you can reuse in your program. That's all. So in our case, we've been able to write thousands of functions. Okay. Let's say in your career as a software engineer in C programming, you've written thousands of functions in order to save you time so that you don't have to go and rewrite it again. In fact, let me ask a question. Who sat down to rewrite all of these functions again? All of these ones. When we were given a task, who sat down to rewrite all of these ones again? Anyone?
I did that.
You sat down to think about what, how do you call it? Put underscore char would be, what this would be, what this would be, or you just went to copy them and paste them in there?
I did copy, but I copied all of them one by one. I did.
Yeah, I mean, like, you see, even that is still work. Imagine if there were 1,000 of them. Somebody will say, oh, I'll use the copy command to do it. It's still work. And programmers, exactly, it is.
On time because of that.
I can see. Sorry for that. But I mean, that's the essence of creating a library. Okay, so that now that we have all of these functions created, we don't have to create them again, like not at all. Okay, so we are going to put all of these things together, then create, how do you call it, a library, so that we can use it anytime that we want. That's the essence of having a library. So after we have created thousands of functions, we are going to archive these. Okay, we are going to archive this. If it was like normal Windows files like PDF that we are archiving, we'll probably be getting something like a .zip file, which I believe most of you are familiar with. Okay, it's just compressed, like compressed all these. So assuming each of these 1,000 functions were 1,000 files. Okay, so all we've been able to do with a library is that we have been able to compile this into a single file that we can reuse anywhere we want. That's the essence of having a library. Then we've learned that we have two types of libraries, the static library and the dynamic library. For the static library, we are going to put together our library file. So this file, in fact, the truth of the matter is that you may end up having a lot of libraries. Okay, so just as we were saying, we have some library for, let's say, math functions. You have libraries for please any other thing, but I mean, you can have a lot of libraries. Okay, some of these things, see, I keep saying that if you don't get the why, relax. Like we'll get to start when we start using them, then you say, oh, okay, so this is why we needed to. Hey, I can only imagine if I didn't create a library for how would this be like. Okay, so some of these things, but I mean, we'll have a lot of library files, a lot of them that we are going to make use in our program, and it makes our lives easier. Imagine if when we started C programming, there was nothing like printf. There was nothing like scanf, and for each of those functions, we had to create our own. You see how many times people cry when they ask them to use _putsha, and we are wondering why is it that there is putsha and you are asking me to go and create _putsha, and every now and then they are asking us to create a new _putsha. Why? We have already created putsha. Why do we have to keep creating it? So every now and then, if you want to use _putsha, you have to create it again. No. That's the essence of having a library. So now we can put all of these mini functions into a library, and we can have a lot of these libraries that we'll use anytime, any day, not only for ALX tasks. After you are done here, if you are working somewhere, you have created all of these functions. In fact, you can even make your functions public for others to also use. Okay, so that's the essence of having the library file. Then after we have gotten this, we can then link it with the actual program that we are creating. By linking it, we'll get one executable. That's when we talk about static libraries. We'll get one executable, and that executable can be run, and it will give the outcome of the program without any problem. So hopefully I didn't end up confusing you. I hope. I really hope so, because I tried my best to try and explain it to the basic level. But if you have any questions, now is the time. Just 3 minutes. Let's take questions and within 3 minutes.
Thank you very much. I appreciate what you're doing.
You're welcome. Yes, I want to believe
mine
it.
is a suggestion. Please.
Okay, sure.
Okay, I know you encourage a lot people to, cut you short when you're explaining something if they have questions. But I do think that even if one has to cut you short, you should at least finish the statements you're making, because I think most times today, when you are explaining something and you're cut short, I end up losing your explanation.
Okay.
I feel like we should just add a little, rigor to it by telling people at least you can finish a statement, then they can now, excuse for question. Instead of,
okay.
I mean, you affected me a lot today. That's why I kept asking a question for that last part, because of multiple questions, and it was cutting off your explanation, and it's making it harder for me to understand. So
All
it's
right,
just
that's
a
well
step
noted.
saying it should be taken, but that's just it.
Oh yeah, it makes sense. So that's well noted. And hopefully everyone in the house has also heard. And what based on that, what I will also encourage is this. I think myself too. I've seen that it affects me sometimes because I tend to even forget what I was saying. Okay, so what we'll do going forward is, if you have a question, you can equally unmute yourself, because the moment you unmute, I feel that someone is about to ask the question. Okay, but hopefully when you're unmuting, it means your place is not noisy, because when there is noise, that will distract me. But you unmute yourself, you hold on and let me land with what I'm saying. Once I've landed, then you ask your question. Okay, and if you may forget, you can pen something down. Unfortunately, I can't be using the chat. Otherwise, I would have said we should be putting it in the chat, but I can't be using the chat if I have to be, because I'm using just a single screen. I have to be moving up and down, and it's even very difficult for me to come back to Telegram to come and see what's happening, even with the video. So I would also encourage that when you unmute yourself to ask a question, wait and let me land, then you ask your question. Okay. Then please, if there are things that you understand too, like we have a lot to cover. So if there are things that you understand, I'll plead with you not to like keep asking the questions, like the ones that you already know. Okay. It's, I don't know, but I feel that today when I looked at the curriculum, I was like, oh, we could even do all the 3 in 2 hours, like the 3 for the PLD in 2 hours. But see what happened. We weren't able to finish one. And not like it's a bad thing, because we need everyone to understand. Okay, like we need at least like 80% of us should understand the topic. And I shouldn't be in a rush to go anywhere, but we should try and optimize our time, because there are a lot of factors in play here. We are looking at time, we are looking at bundle, data consumption and the rest. Okay, so let's always try, at least if your question is straightforward and like straight to the point and it makes sense, it helps us all. All right. So thank you all for joining. Hopefully, I may write some articles trying to explain some of these things as well. So you probably should look out to them, and especially with the last part that we couldn't get working, I'll put it together and share the article around. Hopefully everyone will get access to it. Thank you for your time. I respect you all for being here, and I believe that this is just the beginning. We are all going to grow together, and our dreams of becoming some of the best minds out there when it comes to software engineers will definitely materialize. Those of you who are thinking of quitting, I plead with you, don't quit. It will get well. Okay, it will get better. Thank you, and see you some other time. Bye-bye.
Thank you very much. Thank you.
Thank
Thanks a
you.
lot.
Welcome.
Thanks
Thank
a
you,
lot.
doctor.
Welcome.